In this video, we will go over the assembly process for the VX3000. Here, our goal is to set things up so that your VX3000 will be ready for programming and installation. After that, we will also go over a design specing example to give you a feel on how to design VX3000 systems. Let's start with installing the modules to the frames. Here we will use a VX015DA module and install it on a VX3004 frame. Start by preparing the amplifier module. We need to set it to the correct system voltage. In this case, we will select 70 volts. Next, unscrew the front cover of the frame. Then, proceed to secure it using the fixing screws. Using the provided cables, connect the amplifier module to the frame. Repeat all these steps with each amplifier module on your system. Installing the line level output module is a similar process. To set the frame ID, rotate the ID knobs as needed. If you wish to configure the IP address via software, set dip switch 8 to on. In the case of the VX3008F and the VX3016F frames, the preset relationship between the broadcast zones and the power amplifier line output modules can be changed by the settings of the dip switch inside the front panel. Please adjust the dip switch as needed accordingly. If your system has any expansion hardware, you also need to prepare the VX3000PM or VX3000CT for installation. To do this, you will need to set the IP address setting using the VX3000PM and VX3000CT's dip switches. In this case, since we want to set the IP using the configuration software, we will keep the dip switch number 1 to off for both the VX3000PM and VX3000CT. Now the frame is ready. Replace the covers and proceed to the next step. Now that we have the frames prepped and modules now installed, we will now configure the power supply wiring. We will use the manual RCP1024 and the RCP1UI combo. We need to break out the output of the power supply via distribution block and connect the distribution block outputs to the separate channels of the VX2000DS inputs. After this is finished, we need to connect each separate power feed to the frames, individual modules, and other equipment that need a 24-volt power supply. If battery backup is needed, we need to connect two 12-volt batteries in series to the VX2000DS. If the battery is not charging, connect an 18 kilo ohm load resistor parallel to the battery. To monitor power, battery charging status, etc., we need to connect the VX2000DS to the system via DS-Link. As mentioned earlier, an RS-Link connector can connect in parallel up to 4 microphones. This means a frame can support up to 8 microphones in total. If only 2 mics are connected, one to RS-Link A and B respectively, the VX3000 frame is capable of supplying DC power to both microphones. However, if more than one mic is connected to a frame, each individual microphone must be supplied DC power independently. This can be done either with a tap from the VX2000DS and fan out to each individual device, or alternatively power it using a separate 24-volt DC adapter. Finally, you connect your LAN, analog link connections, your audio inputs, and then your speaker wiring. After this is done, you should be ready for programming. Programming will be discussed on a different set of videos. Let's now go over a sample design exercise to get a feel for the VX3000 speccing and design process. Here, I will try to outline some things to consider when speccing a project using a VX3000 system. To simplify the design process, one should always obtain a set of key functional specifications. In this case, we will have the following. We will have an office and warehouse in the same complex but in different buildings. The office requires background music. There will be 4 zones with the following load breakdown. Zone 1 and Zone 2 are small loads, 80 watts and 15 watts respectively. These will be in the office. Zone 3 and Zone 4 are higher loads, 300 watts and 200 watts respectively. These will be for the warehouse and manufacturing section. The head office, which houses security, requires an announcement microphone. This is an industrial facility and emergency site management is needed. Thus, there needs to be PA integration with the system. It needs to tie in to a third-party control system which is handled by the site management. Also, since this system is mission critical, there needs to be full battery backup in case of a power failure. Let's go over how I would spec this for a VX3000 system. Based on the design specs, we see that this is a distributed system with different areas and different wattage needs. This is ideal for the VX3000. Given the load requirements, I would recommend using a VX3004F for both office and warehouse. Taking the load into account, I would use 2 VX015DA modules for the office for zones 1 and 2, and another pair of VX050DA for the warehouse. Given the microphone needs, I would add one RM300X and one RM200X for the warehouse, and also one RM500 for the office. Since this needs to integrate it to a third-party system, we will need additional contact triggers and perhaps additional audio inputs. In this case, I would add a VX300PM just to be on the safe side. Since battery backup is also required, we would add the VX2000DS to provide battery backup capability. TOA recommends and supplies the manual RCP1024 and the RCP1UI chassis. Here is a complete breakdown of the bill of materials for this project. Here is also a line diagram of the wiring for this system. TOA provides system design services free of charge. Reach out to your local TOA technical support department for assistance in your VX3000 projects. This concludes our video for the VX3000 hardware. In the next set of videos, we will discuss how to program and set up your VX3000 system.